this is Joe, and I guess I'll jump in here. Just for our specific project, I saw that as a need. The risk was how much, the access, how extensive, and I think the contractor had some concerns with that. But they have to bid that risk in. I mean, we weren't describing, or we weren't providing the mapped out locations for them. We did say that they would have to go out there and identify those locations. So we were giving them, at least in the contract, a heads up that they were going to have some of that risk in there. We did not internally spend the time to map out the full mile plus of bridge length in all 4 lanes to do that. But it was very important to do so because really, just from our trial, you were seeing the material leak through the deck panels. So we either were going to lose a lot of the material and lose the effectiveness of it, or and we just didn't want to waste the money, because I mean, the material works well, but it's not cheap either. So we wanted to get the full benefit of the material to stay in those cracks. I think the plan worked out pretty well. How to seal it, we didn't specify, and as Tom had kind of shown in our presentation, we left that up to the contractor to really come up with the innovative way of doing it that was efficient and pretty quick and easy once they did their test and verified it worked.
This is Chris. I was concerned with that with our Manette Bridge also. One of the things that we did look at was going underneath and sealing the cracks before we put the sealer on, or try different viscosities to make sure it doesn't go all the way through. And we chose the higher viscosity material so it wouldn't go through, and we tested it and it seemed to work. So saved us some money, so we didn't have to go through and map the cracks and seal them from underneath. So that was our reasoning.
I've got a couple of questions I'm going to kind of merge here, and they're all sort of in the same vein, but the one I want to start with is a couple of people asked about, is there a typical expectation of the service life of the HMWM sealing? In other words, how long would you expect that sealer effective once you've applied it?
Yeah, that's a good question too, John. Typically, as far as a life cycle, I'm usually conservative when I give a life cycle, but there was a project, and I believe it was back in the early 90s, that was done down in the Florida Keys by Florida DOT. I think they call it the 5 Mile Bridge, if I'm not mistaken, where the high molecular weight methacrylate, the 30% elongation, was used. And they had actually cored it, I think, after the project. And then just recently here, within the last couple of years, they were thinking about a reapplication. I want to say that bridge, the initial application was probably on there for 15 plus years, perhaps. But there was a really good paper that Florida DOT did put together on a high molecular weight use on that bridge. And I want to say it was in excess of 15 years.
Okay.
I think the other thing you have to look at is the location. I think for our snowy passes, if you have studs and chains, it could definitely shorten that lifespan.
Minnesota typically reseals on a 5-year schedule, regardless of product type.
And you've gotten that from past experience, Sarah?
Correct. That was also part of the evaluation we performed during our 2014 research project. So we had 3 years to evaluate those crack sealers, and even after 3 years, we were seeing some adhesion and cohesion failures within the sealers, and we had all different types of products on that in that research study. And so that's where we got kind of that 3 to 5 year resealing schedule. Typically, our crews are on about that 5-year schedule. And we also have snowplow operations that do affect some of the surface sealants as well.
Within your studies, or do you know of any studies where analysis of what the benefit of crack sealing is in terms of either, well, say, cost benefit or service life extension for the deck?
I believe Wisconsin is in the process now of a research project that's looking at different deck activities and looking at the approximate extension, decreased deterioration or extension of service life for those types of activities. Minnesota is in the process of hopefully looking at a future research project that evaluates different maintenance activities and what the benefits of those activities are.
I'm not really surprised that there aren't too many studies, because I don't know that we've been able to do many of those studies. That might provide some good information.
A quick question, just to perhaps to Errol at this point. Errol, one of the benefits we promote when we talk about high molecular weight methacrylates or even MMAs is restoring the concrete strength. Did you or perhaps Sarah in Minnesota, some of your work, do any compressive breaks tests on the cores or samples?
We did not in Minnesota.
No, we have not performed any concrete breaks on some samples that have been treated. You know, if memory serves, our pavement program may have had some data that dates back some time. So, Tom, I would have to research that and to deliver an intelligent answer. Said, you know, anecdotally or empirically, you know, we pretty much widely believe internally that that we do get a restorative capability of that. It's just very hard to take it to design as a design parameter.
On a different topic, there were a couple of questions related to the impact of high molecular weight methacrylate flood seal on decks with regards to friction coefficients. Does it affect the rideability quality in terms of at least friction characteristics? And is there a test that might be used after the application to determine what the coefficient of friction is? Is that even done?
So, you know, in California, the broadcast sand is put on, and I believe that the function of that is to ensure that we give a good friction characteristics of the freshly applied treatment. But as Tom mentioned earlier, you know, stuff wears off pretty quick. And so, you know, once the sand wears, the very top surface wears, and doesn't seem to be a adverse effect on the friction characteristics once that wear pattern has been completed.
Just a critical thing to note too are really having perhaps the number one sands, as they're called, or even target sieves of a 20 and 30 if you're looking for a gap graded clean aggregate. You really want something large enough to provide the friction, so stay away from the fine sands.
Here's a question related to approach slabs. The question is, you typically seal the approach slabs or seal cracks in the approach slabs, or do you not treat the slab when you're treating the bridge?
In Minnesota, we typically seal cracks on the bridge deck and on the concrete approach slabs at the same time.
Yeah, for Washington, we do also.
Here's a question. This is for Tim, and it's not particularly related to deck seal. Someone wanted to know what the typical bridge length that the New Hampshire in-house crews work on, and other than deck maintenance, are there other activities that you use your work crews on?
I don't think we have a typical bridge length, John, that we look at. We, you know, evaluate the work that needs to be done, and certainly the larger decks, depending on the amount of work that's required, it'd be a little bit outside our scope of our own crews that we look to the capital program to address. But we don't necessarily say no to a project that needs to be done based on bridge length. Certainly anything that involves like a deck replacement or something along those lines, and you know, we certainly look at deck length, and we don't typically tackle deck replacements greater than 50 feet with our own crews, but something we scope out and then work with bridge design on in their preservation program. We'll look to see what work needs to be done.
John, somebody had asked the question, what are the thoughts on the value of a thin deck epoxy overlay compared to bridge deck sealers? I think that kind of goes back to the bridge deck preservation cycle, and we talked about earlier, the silane's probably your best defense to begin with bridge deck preservation as far as keeping out that chloride ion, and then advancing to the next phase. And that you're probably, my guess is around 90 cents a square foot, advancing to the next phase, which is the crack treatment, where you're pretty much doubling that. And then the next phase from that standpoint, more significant, would be that overlay, which is, from what I understand, probably around $2.50 to maybe $3 a square foot, if not more, here in the Midwest. So it definitely is based upon cost, but life cycle also factors into that too. And it's the treatment strategy. What does the deck need?
Along those same lines, access can also be a factor. Depending on how often you can actually get out on a bridge deck based on traffic or access might determine what sort of strategy you might be using in different instances. And then John, going back to your question to Minnesota crews, the in-house crews do tackle more than just deck maintenance. They do work on bearings, substructure, superstructure elements, depending on what sort of reactive maintenance is found during the inspection, and it's assigned within our maintenance module. And then certain types of work, we do some overlays, although most of the overlays and deck replacement type work would be done through contract. Major preservation items would be performed through contract.
If we had a little bit of time, you could explain your bridge training school that you use there for your workers, but that's probably kind of outside the topic.
No, I was just going to say, if you'd like me to, I'm more than happy to explain it.
Well, we got a couple minutes. If you want to maybe just give a quick overview of what Minnesota DOT does for training their own personnel.
Sure. As I mentioned, we have 20 in-house bridge maintenance crews, and the size of the crews might vary from 4 on a crew to 13 on some of our larger crews in more metropolitan areas. And we have a bridge maintenance academy. I did talk a little bit about our e-learning modules. So we have some e-learning modules for preventive maintenance activities, flushing, crack sealing, joint sealing, and expansion joint gland repair. But we also have a bridge maintenance academy. We're working on converting Academy 1 to e-learning modules, and those are some of our introductory courses on bridge components and elements, loads and forces, intro to concrete and other types of materials, intro to steel, intro to timber, and intro to design and mechanics type presentations. We also have an intro to bridge preservation and safety and traffic control. And then our Bridge Maintenance Academy 2 and 3 courses are 1 week-long courses. They're in-house led, but we also hire a bridge maintenance supervisor that retired a number of years ago that also has a concrete business, and he comes back and helps to teach the courses. And during that week, then participants build basically 3 small bridges. And so in Bridge Maintenance Academy 2, they build the abutments, and we also build in the laminated areas in a slab so they can try different patching materials. And they work with both our forming materials, they work with steel, they work with concrete, so the typical materials that they'll be using within their repair. And then we talk a little bit about, in Academy 3, we talk about bearing maintenance because they're setting the bearings, they're setting the beams, and they're pouring the deck. In Bridge Maintenance Academy 3, again, we build into laminated areas to do full depth deck patching. They install a strip seal extrusion and have the opportunity to install a gland within that extrusion. And then we'll try out different, like I said, patching materials. But the ultimate goal is then to allow the bridge crews to practice with jacking equipment so they can jack that bridge in case they need to work on bearings. It's kind of a test platform for utilizing appropriate work practices for performing jacking.
Thanks, Sarah. Very impressive. Like I said, I've seen some of that live out in Minnesota DOT, and it is impressive what the DOT is able to do with their own personnel. This is actually the last of 8 AASHTO TSP2 bridge preservation webinars. There have been 7 previous ones. You're seeing 6 of them here because these 6, the video recordings of these 6 webinars are now available at this website that you're seeing on the screen there, and I'll leave it up for a little while so if someone wants to copy it down. With that, I would like to close the webinar. I will say, we'll make an offer. If someone has a burning question they feel wasn't answered, you can send it to me if you will, and I'll try to get the question answered through one of the presenters. My email is hooksj@msu.edu. So with that, again, thank you for everybody who's participating. And I think at this point, we'll close out the webinar.
The preceding was produced by the National Center for Pavement Preservation. More information can be found on the web at pavementpreservation.org. Additional support provided by Michigan State University.